Now you should have been very familiarized with the ideas of numbers. So we begin with the idea of natural numbers, which are numbers such as 1, 2, 3, 4, etc. And then we also have integer, which also include the negative values of these. And then we're moving on to rational numbers, which are basically fractions, say 4 over 5 or 6 over 7 fraction. And then we move on to irrational numbers such as the square root of 2 and square root of 5. And there's an idea that we haven't been able to get over, and that's the idea of the square root of, say, minus 1. Now we don't know, so we have known that this is not allowed. But in order for mathematics to be really for all kinds of numbers, we must find a way in order to work with the idea of the square roots of minus 1. And that is when the idea of complex numbers had came in. And so the complex numbers is basically, say we have the number I, so it is denoted as I. We have the number I, and I is basically equal to the roots of minus 1. So say you want to denote the square root of minus 5, this is equal to root 5 times I. So that is the basic idea of I. And how can we use these numbers? So let me show you. Now usually a complex numbers is denoted as x plus y times I. I here being equal to the root of minus 1. And x here is a real number, and y is also a real number, but this is what we will see a complex number. This is a complex number. And there are two parts to this. So this is what we call the real part. This is what we call the imaginary part. Now as we have the imaginary part is go by y is a real number times I. So y is in fact just a real number, but considering it is y times I, this is called imaginary part. So when it comes to complex numbers, it is mostly about operation on complex numbers, which mean the calculation we can make. So addition, subtraction, multiplication, division, and roots of the complex numbers. Let's talk about those. So here we have the addition complex numbers. So addition of complex numbers is pretty simple. So here we have, say, 3 plus 5i and 10 minus 2i. So say we want to add these two. So what you can do is that you add 3 and 10. So add the real part together. So 3 plus 10 plus here 5 minus 2. So 5 minus 2i. And this is equal to 13 plus 3i. So in addition, you basically add the real part and then add the imaginary part together. So that addition. And when it comes to subtraction, it's fairly the same. So here we also have 3 plus 5i, and we want to minus this for 10 minus 2i. So to do this, we also subtract the real part. So here we have 3 minus 10, and plus 5 minus 2. So it's 5 plus 2 because it would double negative, so that is a positive, times I. So this gets us minus 7 plus 7i. So addition and subtraction is basically operating that operation on the real part and then on the imaginary part, and you get your answer. Now what about multiplication? So multiplication. Say now we have two numbers, so 3 plus 5i, and we have something that we can easily multiply. So here say 2 plus 3i. So we want to multiply these two. Now consider I as being an x. So I here, just consider it as a variable. So if you do that, you just multiply each term. So 3 times 2 get us 6, plus 5 times 2 got a 10i, 3 times 3i, that's 9i, and 5i times 3i, that's plus 15i squared. Now you know that I is being equal to minus 1 roots of minus 1, so I squared is equal to minus 1. Yeah, so I squared is equal to minus 1. And if we have I, say I cube, that is equal to, say this time the roots of minus 1, so that minus I. And so I to the power 4 is 1. So just basically the operation on if it was if this was say a positive real number. And so here what we have is, so I square is minus 1. So here we have, this is 6 plus 10i plus 9i minus 15. And this is equal to, say this is 19. 6 minus 15, that minus 9. Minus 15 plus 19i. So that's how you do a multiplication. So just see I as, say, x. And then just replace I square or I cube with any these ideas about I, and then you got your answer for your multiplication. Now before I introduce division, I want to talk about the idea of the conjugate pair in complex numbers. So what we have is, so if you have numbers 3 plus 5i, so this is conjugate. Then the conjugate pair of 3 plus 5i is 3 minus 5i. That's what we call the conjugate pair. So 3 plus 5i, and the conjugate pair of 3 plus 5i is 3 minus 5i. And similarly, if we have 3 minus 5i, conjugate pair, conjugate complex conjugate number is 3 plus 5i. And why is this special? So the conjugate is special in the sense that if we have 3 plus 5i times 3 minus 5i, this is actually equal to 9. So 3 squared minus 5i squared. And this is 9 minus 25 times 1 square. So I square here is minus 1. So that's minus 1. And this is 25 plus 9, that's 34. So the idea of a conjugate, say the conjugate pair, is that their multiplication is actually equal to an integer. And that has a lot of implication on the division. Now I'll show you what are their why they're helpful on divisions. Let's say division. So we want to divide 1 over 3 plus 5i. And the way when we do division is simply we multiply now if we multiply the denominator with the conjugate of denominator, we'll get an integer. And so if we also multiply the numerator with that conjugate, with that complex conjugate, we'll also be able to put it into the form of x plus yi. So let's just go into a more specific way how to do it. So here, multiply these two with the conjugate complex of 3 plus 5i. So this is equal to 3 minus 5i over 3 plus 5i times 3 minus 5i. This is equal to 3 minus 5i over, now this is 34 as we have done before, 34. 3 minus 5i over 34. So this is equal to 3 over 34 plus, minus 5 over 34 times I. So in the division, the best way to do it is simply multiply both the numerator and the denominator with the conjugate of the denominator, and that is how you get into the form of x plus yi. And even if this is not an integer, even if this is a say another complex number, you still do the same. Also multiply the numerator with the complex conjugate of the denominator and work as it was a multiplication. Now talk about the roots of a complex number. Let's say you want to find the roots of the complex number, say 3 plus 5i, and put them in the form of x plus yi. Now the root of 3 plus 5i is equal to x plus yi. So we have x plus y I square is equal to 3 plus 5. Now here, this is x squared. Now this is plus 2xyi minus y square. So y minus, so say yi square is equal to y square times I square. I square is minus 1. So that plus, that got into be a minus. And here we have this is equal to 3 plus 5i. And so x squared minus y squared is equal to 3. And 2xy is equal to 5. So whichever had I behind it is equal to this, and because this is the real part, this is equal to 3. Now this is two equations, and from these two equations you can actually find x and y. So how do we do it? So here we have 2xy is 5, so we have x is 5 or 2y. We place it here. We had let me write it down here. Place it there. We have 5 or 2y square minus y square is equal to 3. Now this is a bit complex. So say you multiply these two with y square, so here we get 25 over 4. So y square times y square is nothing. And here we have minus y to the power 4 equal to 3y square. Now set y square as say u. This is actually, and move it here and move this here. We have u square plus 3u minus 25 over 4 is 0. Now solving this, we'll get u. And as we get u, we can actually find y. And from that we find x. Now I'm not going to solve this because we have already mastered the solving of, say, quadratic function. But that is basically how you want to find the roots of a complex number. So basically, set x plus y to I, square it, and find x and y. So that is the operation on complex numbers.